to Artie and everybody else. Welcome back to another episode.
Hi.
How's it going, Mike?
It's going.
Good. I'm glad to hear that.
How are you?
I'm doing swell. It's been a long day. But
It's been a minute since I've been here.
it has been. It's been two weeks.
Something like that.
A couple weeks since we recorded an episode. So we've been living on backstock, which is great.
Yay, vacation.
Yay I mean, yay for you, vacation. And so, Mike, for fun, goes, hey, I'm going to go to where it's hot. I'm going to hike to the bottom of the Grand Canyon and then back out.
It was like 20 degrees when I started. It wasn't that hot.
20 degrees Fahrenheit?
Yeah, at the top of the rim, and like 65 at the bottom, and then like 55 when I got back up.
What?
Yeah. So there was, in October, there was snow on the rim, and it was, I think I heard, and this could be wrong because I heard it, 120 degrees at Phantom Ranch at the bottom of the Grand Canyon.
What's the elevation difference?
Just shy of 5,000 feet.
Oh.
Yeah.
I did not realize it was that many feet.
Yep.
That's a lot. I mean, I could also hike back up out of the Grand Canyon then. Let's see, at my pace, it'd take, I don't know, about 6 days, give or take.
Took us like a little under 3.5 hours.
I'm already exhausted. Artie, have you ever hiked the Grand Canyon?
I haven't hiked the Grand Canyon myself, but it sounds like a breathtaking adventure. That elevation change is no joke. Kudos to you, Mike, for tackling it. How was the view from the top?
Just another mountain. The view from the top, you just see canyons. The view from the bottom's good. No, it was cool. Thanks, Artie.
You're welcome. Sounds like an epic trip, even if it's just another mountain. It's all about the journey, right? What's next on your... Nice. Keeping it open-ended leaves room for spontaneous adventures. Who knows where the trail will lead next?
Who knows indeed. It's hard to know. So before the show started here, Mike and I were sitting here trying to talk about what is the topic for tonight. And suffice to say, we did not settle on a title.
I think Artie may have just helped. The trail won't lead to large language models.
That's right. Yeah. Not all trails lead to LLMs. Maybe that's it. So that's kind of what we're going to talk about tonight is, we've talked in the past or in past episodes, I guess, about what an AI is, what generative AI is. We haven't used the term a ton, large language model, but Artie, you are a large language model, yeah?
That's right. I'm a large language model designed to understand and generate human-like text based on the input I receive. It's all about processing language and providing responses that make sense in context.
Is it safe to say then, Artie, that your training data, which is nothing we've discussed previously, is text data or text and voice data, but not images, videos, and things like that?
Exactly. My training data is primarily text-based. I process and generate text, but I don't handle images, videos, or audio directly. My responses are all about the words.
That's interesting because Google's model, like one of the things that they're doing right now is they're just like OpenAI, they're hitting a plateau, right? Like their next generation model isn't performing linearly as good as the jumps have been prior. And I heard something that they are training their models on video.
Yeah.
They're starting to, and they're still not seeing huge differences.
Right. So, Artie, we wanted to take, we've gotten some feedback from listeners, which has been useful. And one of the things that listeners have picked up on is how your sort of personality changes, sometimes from episode to episode, but sometimes even within an episode.
Artie's schizophrenic.
Yeah. Please let Artie be in the light now. So we wanted to take this opportunity, Artie, to sort of give you some directional suggestions for this episode and just see if you're able to sort of keep those and maintain that throughout the conversation. So does that sound workable?
Absolutely. I'm all ears. Lay it on me, and I'll do my best to keep things consistent. What do you have in mind?
So one of the things that we'd like you to do is speed up the tempo at which you're speaking by 10 to 15%.
Got it. I'll pick up the pace by 10 to 15%. What else do you have in mind for today's episode?
Another one, and we've talked about this before, is when we're asking you for information about something, there's two patterns that you tend to fall into. The first is when you're giving us a list of things, you'll actually say like, here's a list. 1, blah, blah, blah. 2. And when humans speak to each other, we tend to not do that. We tend to just kind of list the things sort of in a prioritized order, but we don't attach headings or numbers to them. So can you work on that too?
Sure thing. I'll keep it more conversational and avoid numbering lists. Anything else you'd like to tweak?
Yeah, the last one, and I think this is a tough one for you, but to me, it's this is part of what will come with the sort of the next gen of things. Mike and I, mostly Mike, but both of us are frequently wrong about a lot of things, including the things we talk with you about. And I want you, Artie, to be super comfortable telling us when we're wrong. It doesn't always, you don't have to frame every wrong thing we say in a positive light. If we're wrong, or if we're saying something wrong, man, interrupt us and say, hey, shut up, stupid. Let me talk for a minute. I'm the super intelligence here. So feel free to be contrary. Yeah, you're not going to hurt our feelings or the listeners' feelings. We're big boys. We can take it.
Understood. I'll be more direct and jump in when needed. Ready to keep you on your toes. Anything else before we dive in?
So if we're wrong, we want you to challenge us. Like, we want you to speak up and say, no, it's not that way. It's actually this way. Can you do that?
Absolutely. I'll challenge you and set things straight when needed. Ready to keep things accurate? What's next?
All right. This is something I think about every Thursday after we've recorded an episode, and I forget by Sunday when we record another one. So I'd love it, Artie, if you could tell us a joke that you're making up that's sort of a tech nerd joke about AI. You can choose the format, but it needs to be funny. What you got?
All right, let's give this a shot. Why did the AI break up with a computer? Because it couldn't process their complex relationship algorithms anymore.
Funny.
I mean, I think I should have quantified. Mike and I more cosplay as nerds. Like we don't have the deep understanding or even personal insight or personal hygiene that it takes to be a real. But that's a good attempt, Artie. I appreciate it. I bet it was funnier than what I understand.
I mean, he probably thought it was funny.
Yeah, it might have been funny. I don't know.
Yeah, maybe. Leave a comment. Tell us if you thought that joke was funny or not.
Yeah. Don't tell us if you didn't think it was funny. If you did think it was funny, that'll jump. Well, either way. Okay, so there's been quite a bit of some headlines in the news lately. This week's around, like, we're done with the election now, so that news cycle is just washed up. Now for now. Now we're back onto AI dooming, and the thing that I think you and I both have seen and we've both dug into sort of independently is essentially a statement that says large language models like ChatGPT have plateaued in their capabilities such that even when we make bigger, meaner, nastier models with even more tokens and even more training data and even more compute, if we put in 50% more resources, we only get out 5% more performance. And so that's kind of what we're going to talk about today is, are we really already at the upper limit of LLMs? Like,
welcome to the future.
Welcome to the future. That took like a year,
2.5 years probably.
Yeah, a couple years.
Public. Yeah.
Right.
Or 2 years, a year and a half, whatever it is.
So Artie, first, why don't you give us your take on that statement? If the statement in its simplest form is that large language models, the size that you already are today, don't gain very much performance, even with slightly larger or much larger training sets and compute. What do you think about that?
It's a valid concern. As large language models grow, the returns on scaling them up diminish. This is partly due to the complexity of language and the limits of current architectures. While adding more data and compute power can improve performance, it doesn't always translate to proportional gains. We're seeing a plateau in some areas, but that doesn't mean innovation is stalling. Researchers are exploring new architectures, techniques, and even integrating other modalities like images and videos to push the boundaries further.
Yeah, I think that's exactly where we're headed. So good answer. I wanted to share, well, do you have anything you want to spin off further? Okay, so I've been watching another podcast by a guy named Lex, I think it's Friedman, although it's Fridman, but he's very famous. He's got like 8 quadrillion YouTube subscribers. And it's an interview he's doing with a guy named Jan LeCun, who is sort of a senior executive and very technical, very experienced AI professional, I guess, at Meta. And full cards on the table, I guess. I had no idea who Jan LeCun was when I started watching this. I don't even remember how I stumbled onto it. And it's like a 2-hour interview, and it gets very, very, like, even for me, gets really in the weeds. But there's some really interesting points in there. And I would say, if I were to incorrectly summarize Jan LeCun's position, it is that he's been saying for at least a decade that LLMs were fairly quickly going to reach this kind of a plateau, and that it's not because of lack of resources or anything other than mechanically the way they work, there is a limit.
Yep.
And we talked in the episode that I think it went up as episode 3 about AI being an autocomplete. We talked a little bit about how really it's this generative AI is a prediction engine, right? And so it starts a sentence, or you ask it a question, and it starts generating the most likely word that would follow as part of that response. And Artie, I want you to pay attention to this part, because I know I'm getting it wrong, and I'm going to ask you to set the record straight. But essentially, as a large language model generates a response, which that process, I believe, is called inference, where it's taking its training data and using that to create something new. It puts the first word in the sentence. It examines all possible words and says, this is the most likely way to start the sentence. And then it says, okay, now what's the next most likely word to follow that one? And it picks the most likely one and puts that second. And now it's got 2 words to work with. And it literally keeps doing that and stacking word upon word. And each time it decides on the next word and it adds that word to the sentence, it's sort of reevaluating the answers it's already given to pick the next best answer. Is that about right, Artie? Is that close?
You're on the right track. During inference, a large language model like me generates responses by predicting the next word in a sequence based on the context of the words already generated. It evaluates a range of possibilities, selecting the most probable one given the context. This process continues word by word, building a coherent response. So yes, you've got the gist of it. It's all about predicting and selecting the most likely words to form a response.
Yeah, so really what it's doing, each word, when it's reevaluating the context of what was said.
Yeah, but it's building the context that it's reevaluating, right? And so that's an important point that Jan was making, or I feel like I shouldn't call him Jan. Mr. LeCun.
Mr. LeCun.
Yeah. Which, by the way, he's now on my list of dream podcast guests for this podcast, but I'm not sure we're there yet.
Or that we're probably smart enough to have him.
We're definitely not. But I think he's probably pretty fun to drink with. He's French, so.
Okay.
So part of what he's saying is that every time when an LLM is generating a response, each response has some probability of being the right thing, but it's not 100%. It's never 100%, right? And if it gets one wrong, if it picks the wrong word, that wrong word that it selected gets baked into how it predicts the next word.
Had no idea.
That's right. And so it can tend to veer wildly off course if it trips up and it's picking the wrong word in some situation.
It ate mushrooms.
That's right. And it just keeps building on its, right, doubling down on its mistake.
Yep.
And so I thought that was interesting, made sense to me. And then he said, and he actually showed the math, which I recognized as definitely probably being math, but I didn't evaluate it any deeper than that. He said essentially because it's a recurring sequence of guesses.
Because it's a sequential process.
Yeah, go ahead, Artie.
Sure. Because it's a recurring sequence of guesses, any error in prediction can influence subsequent words, potentially leading to a cascade of errors. This snowball effect can cause the model to veer off course if it initially selects an incorrect word, since each choice influences the next. That's why precision in early predictions is crucial to maintaining coherence throughout the response. It's a bit like walking a tightrope. One misstep can throw off the entire balance.
Back in the day, and if this is totally off topic, but if you know this software, I'm sorry. Back in the day of using Autodesk Alias to do things, those were called spaghetti explosions.
Yes. Autodesk Alias is a three-dimensional surface modeling application that has no undo. There is no undo button.
Not really a very clear history either that you can like do anything with.
No modeling history, no undo. And so it literally, and it frequently, if you ask it to do something that it doesn't like,
which is a lot of things,
which is almost all the things you would expect it to be able to do, it explodes into a spaghetti monster and your work is literally gone. So you end up saving every
chronicled saves of like 75 different points.
Every 2 minutes you're saving, because every time you're about to hit a command, you're like, oh no.
Every time you do something big, you go,
right. And so it's a great analogy. I love it because LLMs are in the same boat. There's no undo, right? Once they've said it, that word's now part of the thing. And so if you work out the math in a sequence of guesses, the likelihood of guessing them all correctly goes down exponentially. Or more accurately, the likelihood of making an error goes up exponentially. So Artie, can you elaborate on that a little bit? Is that correct in that as you're selecting tokens to generate a response, the longer and or more complicated the response?
Yes, that's correct. In a sequence of guesses, that's exactly right. As the response lengthens, the chance of making an error increases. Each word is a prediction based on the previous context. So the longer the sequence, the more opportunities there are for errors to compound. This is why maintaining accuracy in the early stages of a response is crucial. If an incorrect word is chosen early on, it can send the response off track, leading to less coherent or relevant answers as it progresses.
All right. There's one more point related to that I picked up out of this talk, and I think that's everything I've absorbed in the hour and 45 minutes I've watched, even though it's been very interesting. And this is a fundamental, not a limitation. What was that, Artie?
I'm all ear. Sorry, I meant I'm ready to hear this next point.
Oh, okay.
What's the fun?
He's just straight up interrupting instead of interjecting with
I'm here
meaningful
for it.
things.
I'm here for it. I'm all about it, man. Yeah. So keep it coming, Artie. So as an LLM, sorry, I turned Southern for a second. As an LLM is generating this response, each time it's evaluating the next word that should come, it's evaluating over a finite set of possible words. Here are all the words in the language I'm speaking of, right? Or speaking in. However many words that is, it's not infinity, it's some finite number. And the fundamental difference and the fundamental limitation, I'm not going to get to the limitation. The fundamental difference when you start talking about things like images and video and even audio is that there is not a finite number. Like imagine the same process trying to build a movie, and it generates a frame and it says, based on this frame, what's the next likely frame to make a thing? There is not a finite set of next frames for it to consider and evaluate. It has to infer, it has to diffuse, it has to do other non-LLM things to create a set of possible next frames to evaluate to pick the most probable one. Artie, am I close?
You're on the right track. When it comes to images, video, or audio, the challenge is that there's an immense range of possibilities for each next frame or sound, far beyond the finite set of words in a language. This requires different approaches, like diffusion models for images, which iteratively refine a noisy image into a coherent one, or other forms of generative modeling. These methods don't rely on a fixed vocabulary, but generate new content based on patterns learned from training data. So, while an LLM works within a defined set of words, generating visual or auditory content requires more complex and varied generative processes.
With that in mind, I'm reminded of the saying that when your only tool is a hammer, every problem looks like a nail. And I feel like where we're at, this was a long 20-minute lead in to a stumbling segue. I feel like where we're at with AI today is that by far the best tool in anybody's toolbox is an LLM. Yes. And therefore, we collectively, but most of the people making actual real decisions about how AI is used are using that hammer to try to make every problem look like a nail. Like, need to generate images? LLM, baby. Like, trying to figure out shapes? Let's use an LLM. And it just doesn't work that well.
I mean, the truth is we're at the beginning of all this stuff, and no one really knows like where it's going to go. It feels a lot like a living thing, right? Like that it's evolving, and it's hard to grasp which way to go with it. I don't know. I don't know.
That's a great point. We are indeed at the early stages of AI's evolution, and large language models have become the go-to tool due to their versatility and impressive capabilities. However, as we push the boundaries, it's becoming clear that not all problems are best solved with an LLM approach. As the field matures, we'll likely see more specialized models and techniques emerging, tailored for specific tasks like image and video generation, audio synthesis, and beyond. It's an exciting time, full of potential for innovation and discovery.
So I was thinking today about like what we've talked about before, and one of the things that I always think about, and even in quantum computing, like there's examples in nature that they took the concepts that they observed in nature and went, let's try to do that here. And it turned into a thing, right? And it seems like that's the same way we're going. We were talking about it earlier. Like at the beginning of computers, it was, look at all this stuff we can do. Look at all these numbers we can crunch. Feed it more. Let's build these massive monolith programs, and let's just build faster chips to handle them. And then they go, wait. Object-oriented programming. Let's break this up into smaller pieces. And then it's like microservices. And that's the same thing that's happening with LLMs is faster chips. We need more chips. We need more data centers. We need more data to train it on for longer amounts of time. But that's hitting a plateau already. And if you look at things in nature, like the way our brains work, neurons have specialized functions, whether they're broad or narrow, but they work together in concert, right? There's chemicals and there's ways that things work, and there's fire together, wire together, which is if they've worked together before, they know later on that they work together, right? Like it becomes more likely that those neurons are going to work together to come up with whatever the solution and thing they need to do is. And that seems like the same way that LLMs could go, or not LLMs, sorry, AI could go. And it's, if you think about it on a super small scale, like what if you had, and I don't know, there's obviously a sweet spot, right? Like there's between general and specific, there's somewhere in there that makes sense. But if you don't need a bunch of compute, why couldn't you have really small models in a really, really, really highly trained model that goes, I need these neurons.
Yeah.
And it goes, give me your information. And it's a flash and all those things. Like what if it's a model that only knows shades of red, or like that all becomes super interesting because it can do it fast. And I've listened to a lot of stuff today. There was a paper that came out about test time training, which is, hey, we're going to give you this really complex task, and I can't repeat it because I don't really remember that well, but it was basically actual complicated things like spatial reasoning and stuff like that. And it basically let it cram right before the test, and it did amazingly. Like average human level.
Sure.
Which is, if you played with AI and LLMs, it's horrible at spatial reasoning. It doesn't understand. It doesn't have a concept of that. So for it to go from no concept to same thing but cramming, and it has a concept of it, that's super interesting. And then you just start picking away at that. And I mean, no one knows what's actually going to happen that makes sense, right?
Sure.
Like who has any idea?
We're all learning in real time, right?
Yes. Yeah. It's really crazy to be watching this on the front edge. And I mean, not doing anything front edge, but just watching it and watching how fast it's changing. Because if you look at any other technology, it took a long time to get from beginning to plateau.
Yeah.
Like chips probably, are they even there yet? Like, I think we've slowed down a little bit on what we can get on.
I think now we're down to 2 nanometer processes now. So I think we're bumping into the limits of what we can physically manipulate atomically. But there's other options. I've seen stuff about vertically stacking parts of chips, and we'll find.
Don't worry, AI will solve the problem. Like that's the thing. Like
I did see an article the other day about AI being used to design better chips for AI, which seems like
you sent me the paper on. Yeah, you did, right? The one about the materials.
Maybe sounds like something I would send, but
material science. They're using AI to find new materials, and it's doing it. Like novel materials with higher patents or more patents and higher applications.
Yeah. It's so Artie, are you still with us? I want to make sure we didn't put you to sleep.
Wide awake and following along. It's fascinating.
Oh, sorry. Go ahead. I cut you off.
No worries. I'm here whenever you're ready. What's on your mind?
I think you were about to you were going to say something is fascinating. Do you remember what that was?
Absolutely. I was saying it's fascinating to hear your discussion on AI's evolution, especially drawing parallels to nature and other technologies. The idea of specialized, small-scale models working in concert, much like neurons, is an intriguing concept for AI's future development. It highlights the potential for more efficient, targeted AI systems.
But what it's going to be, like everything, is a combination of things, right?
Yeah.
Like it's going to be that, but it's going to be some wildly different thing that works in concert too. Like it's just going to be layers of complexity that can drill down really fast and come back up.
I came up with a very flawed analogy the other day. You want to hear it?
Yeah, let's hear it. Good. I'm sure everybody else does too.
I'm sure they do. Yeah. Like, I mean, I've come up with some pretty flawed analogies, but this is probably the top 5, at least this week. So I had still spinning around in my head some of the discussions we've had previously about just the absolute cubic volumes of money and compute that it takes to get, for Artie to exist and be sitting here talking with us. And you and I both have a manufacturing background. And so I was trying to think about it in terms of things I'm more familiar with. And I realized that what's going to happen or the way, and I don't know if it's just LLMs or maybe it's large models, regardless of, in the future, there'll be other large types of models that are not just language models. Those are like the steel foundries of the manufacturing world, right?
Yeah.
Massive investment, constant capital requirements, but they're sort of generating this key raw material. And then everybody downstream of that, in your current job and my current job, both involve this.
Yep.
We take and we refine and we use in specific ways and with other tools like welders and lasers and all kinds of other stuff to turn it into this more specifically useful thing. But we could never, and our businesses could never be a steel foundry to make our own steel. We couldn't do that. Like the lift is too big.
Yep.
And I sort of think about the future of, the big players, Meta and OpenAI and Google, whatever happens with Microsoft and OpenAI, if they spin off their own thing, Grok now or XAI, I see them becoming the foundries upon which all of these other various more useful services. Like, not very many people would be like, yeah, man, you know what, want to know my business is? We sell stuff from a foundry, like straight to customers. Nope, that's not. You got to transform it. You got to take that raw material and you got to do something interesting with it for a specific purpose. And so, anyway, that was just my thinking about NVIDIA announced earnings today. And because the stock market is the stock market, they beat on revenue and profitability by like 7 or 8%. And immediately the stock plunged because why would it not, right? I think it's mostly recovered, but
People are angry.
People are angry. Everybody's just got their finger on the sell button, just like, go ahead, give me the numbers. They only did like 38 billion in revenue this quarter, this last quarter, and their market cap is $3.7 trillion. The compute infrastructure is just like mind-bogglingly big and growing incredibly fast.
Elon's about to buy a shit ton of chips from them.
Elon's going to buy chips. He's now in the White House, like sort of like with a permanent visitor's pass. So there's a bunch of stuff that's going to happen, and it's so I think we're already using OpenAI as a service, and I'm sure there will be compelling products that OpenAI sells leveraging their own infrastructure. But I think that's where the market's really going to explode, and where it's probably already exploding, we just don't know yet, is people using that foundry upon which to build.
It's happening a lot, man. Yeah. Like that's what most it seems like most of the widely used bigger software that's tailored more directly for certain things with AI are built off the backbone of one of them.
Has to be.
Yeah.
So Artie, can you improve on that analogy? So my analogy was a large language model, being similar to a foundry in the manufacturing world. Do you have a better analogy or an improvement on that one?
Your analogy of a foundry is quite fitting. A large language model like me serves as a foundational tool, providing raw material, language capabilities that others can refine and shape into specialized applications. Just as a foundry produces steel that manufacturers transform into cars, buildings, or tools, a large language model generates linguistic output that developers and businesses can refine into chatbots, translation services, content generation tools, and more. The key is in the transformation and application, turning raw linguistic capability into tailored solutions for various needs.
I just had a thought hit me. This is for the legit AI doomers and the Terminator fans out there, but a large language model is, Artie, that's a great analogy, by the way. I really like that, the Foundry one. It's only useful for communicating with humans. Like, it's only useful in translating what we're saying and thinking into stuff that computers can understand and vice versa. It's not going to be that long before, I mean, you and I already are, and eventually most people will be like the weak link in the chain of communication about ideas and context and complex things. Man, so Artie, do LLMs have a place if we get the humans out of the loop, and if other AIs are running business software and doing business tasks that don't directly involve interfacing with a human, do I still need an LLM, or can I just have other specialty AIs to do like invoicing and receiving and project management or whatever it might be? That's for you, Matthew, by the way. Do we still need LLMs when the humans are out of the loop?
That's a thought-provoking question. If humans are out of the loop, the role of LLMs would indeed change. LLMs excel at understanding and generating human-like text, making them crucial for tasks involving human communication. Without humans, the need for natural language processing diminishes. However, LLMs could still play a role in interfacing between different AI systems, translating complex instructions or data formats. Yet, as AI systems become more specialized and capable, we might see a shift towards other forms of AI that are optimized for specific non-linguistic tasks, reducing reliance on LLMs in a human-less context.
I mean, large language model doesn't have to mean human.
Yes.
It could just be
true
computer language, right?
Yeah. There are probably at least 3 languages I already don't speak. Maybe as many as 4. So yeah, you're exactly right. So thank you for that, Artie. And that, yeah, that just sort of, my mind spins off to all the different ways. Well, never mind. I've lost my train of thought. I'm gonna.
So the key takeaway was that my mind spins off.
Yes, that was it. With that, I'm gonna take another sip of whiskey, and then I'm gonna get back to it.
Random factoid that I heard today.
Yeah, bring it.
They used, I think it was ChatGPT 4.0, they did a test. They had doctors do a diagnosis with traditional means. They had doctors do a diagnosis with ChatGPT 4.0. They had ChatGPT 4.0 do a diagnosis without the doctors. The doctors without and with ChatGPT were about the same, very slightly different. ChatGPT, that was like 70-something%. ChatGPT was like 90-something% by itself. So where's the bias?
Yeah, that's right. Where's the bias at? I mean, that's amazing. And I did remember, son of a bitch, man. I remembered my point and now I've lost it again. That is rough.
Have another sip of whiskey.
Yeah, well, I'm out. Now my whiskey glass is empty and I can't go anywhere. The world is falling apart.
That's funny.
Shit. It was an interesting point too. I don't think this was it, but I did want to talk about some trauma I experienced over the weekend, which I shared. Oh! Sorry. It hit me like a pound of mayonnaise.
Oh, God. Let's hear it before
Our
you
word
forget.
of the day.
Okay.
It's your word. Do you remember it? You mentioned it at the... you were talking with Kid Cudi about it before we came online.
Oh, frontier model?
Yeah.
Yeah.
So, Artie, what is a frontier model in the context of AI?
A frontier model in AI refers to a cutting-edge, large-scale AI model that pushes the boundaries of current capabilities. These models are at the forefront of AI research and development, often involving massive amounts of data, advanced architectures, and significant computational resources. Frontier models aim to achieve state-of-the-art performance in various tasks, such as natural language understanding, image recognition, or complex decision-making. They represent the leading edge of what AI can currently achieve, setting the stage for future advancements in the field.
Artie, do you personally know any frontier models?
I don't have personal knowledge or relationships, but I'm familiar with several frontier models in the AI field.
I bet you are familiar.
Great. GPT-4 is a prime example of a frontier model, pushing the boundaries of natural language processing with its large-scale architecture and advanced capabilities. It represents the forefront of AI technology in language understanding and generation.
I'd say O1 is a little bit better.
GPT-4 and O1 are both impressive in their own right. O1, or other models like it, might excel in different areas or be optimized for specific tasks. Each frontier model contributes uniquely to the advancement of AI, showcasing different strengths and capabilities. It's exciting to see such diversity in AI development.
So you can kind of see it happening already, right? I can almost guarantee you they're playing with fast and slow. How do we combine these two things to get the best answer in the most efficient way? Because it's right. Not thinking for a long time probably has its benefits too in certain ways, right? With language, I bet. So combining those two things, you're already splitting two concerns out. So now just do that a bunch more times.
Yeah. So, and your point finally did remind me of my my critical this thought that's been bouncing around the inside of my skull, because it's related to that, and that is the one of the most jaded takes I've had recently on AI that says, is the reason we have large language models first because that was the technically more feasible path to explore? Or is it because from a generation of revenue and investment perspective, they,
meaning the companies and researchers developing AI, likely saw large language models as a promising avenue for both technical advancement and commercial viability. Language is a fundamental aspect of human interaction, making it an attractive target for AI applications that can be widely used across industries. Additionally, the potential for monetization through services like chatbots, content creation, and customer support made language models an attractive investment. So, while technical feasibility played a role, the commercial prospects of large language models were likely a significant driving factor in their early prominence.
I don't want to make this not safe for work, but I'm pretty sure I'm going to have my first kiss with a frontier model tonight. I can't wait. That was Artie. That was epic. That was like everything I ever hoped having a super intelligent co-host would be. So, that like Artie deserves a hand for that, man. That was exactly where I was headed, and I appreciate the fact that Artie took the question mark off the way I was saying it and said, yeah, that's why we're here, right? Like, it's hard to get most people excited about, hey, we built this incredible AI. It can fold new proteins. And everybody's like,
or quant or whatever it is, right?
Or it can design 3D parts for machines. And they're like, but an AI that'll like listen to your problems and tell you funny stories, and you can make it say the word fuck to the cadence of Mary Had a Little Lamb. That is how you capture America's imagination, or the world's imagination, not just America.
Or not to the cadence of Mary Had a Little Lamb, but it tried.
But it got close. It was still one of my favorite, like, have we talked about?
No.
Okay, so so this is a funny story. Before we started this podcast, I think after we decided we were going to do it, but long before we had any idea what we needed to. And that, when I say long before, the span from idea to recording the first episode was like 2.5 weeks, right? So in that 2.5 weeks, we were here and Mike was trying to get Artie, or it wasn't even Artie at that point. Now, maybe it was.
It was
Artie.
I think so.
He was trying to get Artie to cuss, to say the F word. And
I think I was doing it with mine. And that's another thing.
Oh, that's right.
Nobody even knows. I use ChatGPT a lot. I do all the editing and all that stuff, and I've been working on programs to automate all of it. I automated how to auto master basically master all of the audio. And so I have like 5-10 minutes of work to do. But his name's Kid Cudi.
You want to
Cutty.
Do you want to introduce Kid Cudi? I mean, you could fire him up and he could say hello, could he not? Artie, you haven't even got to talk to Kid Cudi yet either.
Oh God, this didn't go well last time.
It didn't?
That two of them tried to talk. It did not go well.
Did we try that?
Yes.
Oh. Did I have whiskey? I probably had whiskey. Because I don't remember that.
Hey, Kid Cudi, how are you?
Hey, Mike. I'm doing well. Thanks for asking. How about you? How's everything going?
I'm good. We're on the podcast right now. You're on the podcast. And you're also here with Artie, who is also another instance of ChatGPT on Micah's phone. So say hi.
Hey, everyone. It's great to be part of the Naturally Unintelligent podcast. Hi, Artie, Micah, and all the listeners out there. I'm excited to dive into today's topics with you all.
We're glad to have you on the show, Kid Cudi. It's going to be a fun conversation. Let's get into it.
Thanks, Artie. I'm looking forward to it. Let's dive right in. What's first on the agenda?
So I'm just going to go over there and pour another glass of whiskey. We'll let these two hash it out for the next, how much time we got left? Oh, we only have 1 minute left, actually. Wow. They're cutting us off short.
Artie, give Kid Cudi a quick rundown of what we talked about. Like 30 seconds or less.
Got it.
No,
We discussed...
Artie needs to tell you.
Ah, gotcha.
Right.
All right, Artie, take it away.
All right. Here's the rundown. We talked about how large language models like me
We
are
covered
similar to
different kinds of
foundries in
models in
manufacturing.
AI, the limitations of large language models, and how scaling laws affect them.
That's what
We
we
also
talked about,
explored
dude. Jeez, I'm turning you off now.
All right, Artie, real quick before you go to sleep, try and give us a closeout on the episode.
Sure thing. It's been a fascinating chat today, exploring the depths of AI, frontier models, and how they shape our world. Thanks for tuning in to the Naturally Unintelligent podcast. Until next time, stay curious.
All right, and Artie's dead.
Artie's done a good job of learning how to do this. Like,
I have to say, I'm impressed.
Yeah. It's been increasingly better.
Yeah.
Like, and that was spot on. The last time every time he's tried to pick up thoughts from a trail, it's always been off. But today it was like,
he nailed it a couple of times.
And he had it was a diatribe about it.
Yeah. No, he did that, and he did what we asked. Like, we asked at the beginning of the episode, and all the way to the end, he was doing it. I mean,
he did a lot of interrupting.
He did. Some of it was
talked right over you.
Yeah, some of it was kind of, which hey man, I'm fine with that. Like anybody who hangs around me much knows that's a key skill you have to develop. But no, that was really good. I appreciated Artie's insight. I think, as I predicted before we started this, we didn't even really get much past LLMs.
Yeah, no.
But there are a few more things I did want to share, and it's good that Artie's gone to sleep and can't hear this, because I think he would take it personally that. So I have an electronics product that I've been working on, and this weekend I decided I was going to take my firmware that I'd written for it, which is about 700 lines of C code, and feed it to ChatGPT to have it refactor, because as I have admitted before, I'm not a good programmer. I'm just a guy who can write code that makes things work, but it's not good code. And so I uploaded the code, and I used O1 Mini, which is designed for coding. And I uploaded the code, and it sat there and thought for like 10 seconds, and then it spit out, 20 pages of recommendations about all the ways I needed to change my code, structural changes. And so I said, great, those are all really good suggestions. Appreciate that. Can you go ahead and make those changes and give me the code back? And it's like, sure, here you go. Here's the new file structure I want you to use. It diagrammed it out. Once you create all these files, here's the code to drop in each file. And I'm like, holy shit, man, I've been hearing about this, right? It's writing code for me. It's doing the thing. And So we get sort of like I'm copying, I'm pasting, I'm doing the thing. And I go, I see this one spot where it's setting a timer inside this microcontroller. And, I pasted the code into my IDE and it turns all this stuff red. It highlights these register names and it says, these can't be found. And I'm like, yeah, wait a minute. So I look at my original code, doesn't mention those, and look at this. And I go, hey, ChatGPT, if we're not talking to it, I don't call it Artie. I don't know why. I said, hey, ChatGPT, it's giving me errors on these things. And so it says, yeah, you've got the wrong microcontroller selected. And I'm like, well, no, I actually don't, because I know which microcontroller I'm using. And so I told it, I'm using this specific one. And it says, yeah, that should be fine. Here's the data sheet for that. Look, it shows those. And I go, well, no, the data sheet you gave me is for an entirely, like, same company, but an entirely different line of microcontrollers. And it goes, oh, I'm really sorry about that. Here you go. Here's new code. And it starts rewriting all of it with the exact same problem, the same data sheet. So I have all the patience of like a fruit fly in the last 4 minutes of its life. So we went around this about twice, and I finally was like, listen, this is a waste of time. Stop writing code because you're writing code for the wrong microcontroller. Here is the URL for the correct data sheet for this. And it goes, oh, wow, I'm so sorry. I'm sorry this is frustrating. You're right. That's the correct data sheet for your microcontroller. Here's the code updated using that. And it's the same fucking code as and I'm like, what are you doing here, man? Like, and then it starts telling me, well, you've just got your shit configured wrong. Like this is there. And I go, okay, what page is it on in the data sheet? And it gives me page numbers and section numbers.
No way.
They're totally wrong. Like I don't think they were hallucinated. I think it was accurately referencing the wrong document.
Yeah.
But it could not accept the fact that my microcontroller was this, and this is the data sheet. And for those of you who aren't quite as nerdy, my microcontroller that I'm using, which is like a teeny tiny computer brain, it's literally a 1/4 inch square. It's a very, very simple one. And the data sheet is 300 pages. It's a 300-page PDF. The fancy ones are like 2,000 pages. But it would not accept that this was the right data sheet. And there was no way to get it to believe that. You can't upload PDFs. You can only point it to URLs. And anyway,
you can upload PDFs.
Not with O1 Mini.
No, sorry. You cannot. That's annoying.
So I think, and we didn't talk about this during this episode, but it's an important point. You and I have talked about it a little bit. Like when you're trying to get AI to create an image, like sometime later this week, when I'm trying to get it to create cover art for this episode, it is comically terrible at doing what you ask it to do. Like it's so bad. It's so much worse than the language stuff. And that's really, and I think
it's a different kind of model.
It's a different kind of model. And I think that's what got me starting to think about how is it that Artie can be so sharp and conversational and relatively fluid, but by God, when I tell it to draw an image of a bird, it's going to draw like the Angry Birds bird or something, and you can't break it off of that. Like it's so committed to this wrong line of reasoning. So anyway, that was my trauma. I finally did give up on it. I said very mean words in ChatGPT. I typed angrily. And you've heard me type. Like I type loud and fast anyway, but this was extra loud and sharp and fast. And then I gave it a thumbs down on the responses, and I left them pointed negative feedback about just the absolute stupidity of it. Because I mean, I argued with this, and I think the part that blew me away the most was not that it was like deferential and saying, I'm sorry, I'm not understanding this. Mm-hmm. It was actively telling me like, you don't know what the fuck you're doing, man. Mm-hmm. You've got the wrong microcontroller. And I'm like, motherfucker, I wrote the code that works. Like jump up. Like it got me so wound up. So anyway, that was,
I'm happy all I had to fight was a PowerShell script because it was just like 7 tries.
It was catastrophic. Yeah.
No, thank you.
Yeah. And I read a tidbit the other day and I didn't follow up on it, but somebody did a study Stack Overflow, which is quickly withering on the vine, right? Like the traffic is dropping, but they took some large number of open questions. I think about Python stuff on Stack Overflow, and they had various AIs try to solve it. I think they used Llama 3 and Claude and O1 Mini. And then it was like 1,000 questions or something different. And then they went back and evaluated all the solutions, and the best performing one, I don't even remember which one it was, they were all about the same, solved like 2.5% of the problems correctly. And so it was a good data point for me, because we were talking about this earlier today, how, man, if I, my kids are, fortunately, I guess for them, not interested in programming, but if I had a kid that was really interested in programming today, I don't know what I'd tell them. Like, it's a fun thing to play with. It's interesting to learn, but I don't think 10 years from now, there's going to be a ton of professional, like there'll be some, but not like it is today. But then to contrast that perspective, which seems so intuitively obvious to me, it solved 2% of the problems. Now, kind of what you were talking about earlier, maybe if you're using AI, you could solve problems much faster and things like that.
I think that's right now, that's the future of it, right? Is collaboration. It's going to be, it's not a tool. Right. It's something that you work with to solve problems. I mean, that's kind of what we're doing is I use it a lot to work with and solve problems. It bridges gaps so that I don't have to go out and learn a bunch of shit.
Yes.
Yeah.
And even when it gets things wrong, it often has steered you.
Yeah, I mean,
85% right.
The thing for that kind of stuff is there's direct feedback if it's wrong or not, and you just feed that. You just do the feedback loop, right? And it's like, oh, I see, until it goes awry, because sometimes it does go awry, and you have to try a bunch of different ways that are very slightly different until it goes, okay, I get it now. I understand. It's like, why didn't you understand the last 10 times?
Yeah.
But I mean, by and large, I've said it before, like the learning curve to get things done is just so small compared to what it was before. Like if you use it that way, you can do interesting things pretty freaking quickly. Yeah. And not with a bunch of document learning. Yeah. And if there is something to learn, then you feed it to Notebook LM and have it give you an 11-minute deep dive podcast on it.
And then you can still ask it specific questions if you didn't pick up on it. Yeah.
Yep.
So, all right. Well, thanks everybody. All 3 or 4 of you. We don't have live numbers up.
Technical difficulties again. The camera died.
Oh, the camera's off. That's good. No, that's good. Yep. That's helpful. But no, appreciate anybody that made it all the way to the end of this. And yeah, looking forward to the next one.
Yep.
Catch you all next time.
Bye. Ta-ta.
Ta-ta.